Section 2.5, Summary of Newton's Laws. So in this section, you guys, we're just going to go back over the three laws and just kind of reiterate them, essentially. I want you to definitely know these and to be able to explain them. You should be able to not only list out their names, essentially, the law of inertia, law of acceleration, action-reaction law, but you should also be able to describe them in your own words. And so I'm going to give you a chance of me essentially describing them in my own words, for you to kind of hear that and be able to use that in the future. So the first law is the law of inertia. The law of inertia is basically just saying that you need a force in order to change the motion of an object. That object will keep doing whatever it's doing until you apply or something applies a force to it to change it. No force means no change in motion. And if you think back in the last chapter, we talked about static and dynamic equilibrium. In both of those cases, there maybe forces, but the sum of those forces is zero. There is no external net force. And so because of that, the object doesn't change motion. Static equilibrium means it just sits still. Dynamic equilibrium means it just keeps moving at the same speed in the same direction always. Now the second law, again, quantifies the idea of the first law, if you will. It gives you a way to talk about this in terms of numbers, right? The second law is just the law of acceleration. The acceleration is essentially equal to the ratio of the force divided by the mass, or the force is equal to the product of the mass times its acceleration. You will see books write them differently, but what it really implies is that the force and the acceleration are proportional based on the mass of the object. The heavier the object, a similar force is going to produce a smaller acceleration. A lighter object, the force will produce a larger acceleration. And so it's proportional to the acceleration, means as force goes up, acceleration goes up. Inversely proportional to mass. As mass goes up, acceleration goes down for a constant force. And so the law of acceleration is just equating the two. I mean, you could almost write this just as force equals mass times acceleration. And the third law, finally, is the action-reaction law, which we talked about in the last section. Right? The idea that if you apply a force to something, not only does it apply force back to you, but that force is equal and opposite. Okay? And just because objects are of different masses does not mean that they don't experience the same force. It's always the same force. Now, again, the outcomes can be very different. Now, in the next section, we're going to talk a bit about what things do as they move, or things that can be done as they move. I'm trying to tell you without telling you directly, or without using particular words, but the word energy doesn't freak anyone out. So objects in motion have some amount of energy to them, and you see this if you throw a baseball at a window. Right? When that baseball hits the window, it can break the window. It can do something to it. All of the things we've talked about in the first chapter, the ideas of speed and acceleration, and equilibrium, and then in this case, the idea of how forces interact with one another, is so that we can talk about the next part where we discuss the energy of these objects, and why, even though if a bug hits a windshield of a car, they experience the same force, but the bug and the car experience very different outcomes. With Newton's laws, we can only figure out that those outcomes are different. If we add another piece to it, we can figure out why they're different and how they're different. And that's what we'll focus on in the next chapter.